this is the second part of a series of videos on dividing complex numbers. In the first part, we learned the idea of a complex conjugate. In this one, we're going to start with problems that look like this, where we simplify 3 minus 5i. So what we're going to do here is we're not going to want the I in the denominator. So here's the key to simplifying it, is that you do not want I in the denominator. And this is very similar to problems in the denominator. And this is very similar to problems that we see that, for example, from Algebra 1, where we would have a square root in the bottom. So you'd have like 3 square root of 5 over square root of 7. You can look at the algebra review videos to see how to do this, but this is the same kind of spirit. And so the trick here is you're going to multiply the numerator and the denominator by the complex conjugate of the denominator. And then you're going to simplify. So you notice here, we see this problem, we're going to simplify. The problem is that we have an I in the denominator, and we don't want to do that. So what we're going to do is we're going to multiply the numerator and the denominator by the complex conjugate in the denominator. And let's see what happens when we do that. So we start off, we have 3i 5 minus 2i. I'm going to put a parentheses around the denominator here. The complex conjugate of the denominator is going to be 5 plus 2i. But if we take a fraction and multiply the denominator by something, then we have to multiply the numerator by exactly the same thing. And now what we need to do is we just need to multiply the top and multiply the denominator and simplify. Now, to make things easy, what I do usually is I only multiply the denominator first, and then after I'm done, I multiply the numerator. So let's work only the denominator first. We're going to have a FOIL problem. So it's 5 times 5 is 25. And then 5 times a 2i will be a plus 10i. And then negative 2i and 5 will be a minus 10i. And negative 2i and 2i will be a negative 4i squared. The 10i and the negative 10i are like terms, so we add them, then they actually cancel out, and we get 25 minus 4i squared. But we remember what I squared is, right? I squared is simply minus 1. So we're going to plug that in, and we get 25 minus 4 times minus 1, or 25 plus 4, which is 29. Now that's the denominator. Let's do the same thing in the numerator. The numerator is just going to be a simple distributing problem. So that's going to be 3i times 5 is a 15i. And 3i times 2i will be a 6i squared. I squared is minus 1, so that's 15i plus 6 times a minus 1, or 15i minus 6. Now, our standard form is a plus bi, right? That's this form that we generally like to write things in. So we want the real part first. So we're going to write minus 6 plus 15i over 29. And this is actually a fine answer, though it's not exactly how we would like it. We like to separate out the real and the imaginary parts. So our final answer will be minus 6 over 29. Plus 15 over 29i. And that's going to be our final answer. Let's use some simple algebra for a second. So what we have is if you have x plus 3 over 11, that's fine. But if we wanted to, we could break this up into x divided by 11 plus 3 over 11. Now, we don't typically do that because there's no reason to, but we could if we want to. In the same case, in this last problem, we had minus 6 plus 15i over 29. Here we do want to break it up because we would like it in standard form. We'd like a plus bi, where a is the real part and b is the imaginary part. So we're going to break this up into minus 6 over 29 plus 15 over 29 times I. So it's important to realize we're not doing anything different here. We could have always done this. It's just that we don't typically have problems where we see it. So let's do another example. In this case, let's simplify. Let's simplify this time. Let's simplify 4 plus 3i over 5 minus. Let's do minus 5 minus 8i. And I'm going to rewrite this just so that we have a little more room. This is the same problem. It's just a little bit more difficult than the problem that we just saw, in the sense that there's more arithmetic, more algebra. But the first thing we do is we find the complex conjugate of the denominator. So the denominator complex conjugate with minus 5 plus 8i. Remember, only the term with the I in it will change signs. But if you multiply the denominator by that, you have to multiply the numerator by exactly the same thing. And basically what we have now is we have two FOIL problems. We have a FOIL problem in the top and then the bottom. So what we're going to do is we're going to FOIL both of them. And just to make it easier, what I'm going to do is I'm just going to do the denominator first, and then I'll finish it up by just doing the numerator. And with practice, this becomes much faster than it appears. So negative 5 times negative 5 is a positive 25. First, outside, inside, last. So it's outside. So it's minus 5 times 8i is a minus 40i. And then inside is minus 8i times minus. That's a plus 40i. And then last is a minus 8i and a positive 8i, which is a minus 64i squared. Let's keep working on the denominator here. The negative 40i and the 40i cancel. And the I squared becomes a negative 1, so you get 25 minus 64 times a negative 1. Or 25 plus 64, which is, I believe, 89. I might use a calculator just to make sure. And that's correct. Now let's multiply the top. Again, this is also a FOIL problem, so you have 4 times a negative 5 is a minus 20. Then you have 4 times 8i, which is a plus 32i. 3i times minus 5 is a minus 15i. And 3i times 8i is a 24i squared. Now we're going to combine like terms. Now notice here, when you're multiplying the denominators, the i's cancel out, right? But in the numerator, that's not necessarily going to be the case. 32 minus 15 is 30. I'm going to use a calculator for that. 32 minus 15 is going to be 17. So you get minus 20 plus 17i plus 24i squared, but I squared is just a minus 1. Minus 20, and that's a minus 24. Minus 20 plus 17i minus 24. The minus 20 and the minus 24 become a minus 44. Minus 44 plus 17i. We always want to write it in the form a plus bi, right? So we want to write the real part first and the imaginary part second. That's right. But now we want to break this up. So our final answer is minus 44 over 89 plus 17 over 89i. And I might just check to make sure that 17 over 89 doesn't simplify. Don't think that it does. And that's my final answer right there. Now, sometimes you'll get a problem which is actually a fair amount easier, and you can do it two different ways. So let's say you had this. Let's say your question was simplify, and let's say it's 4 plus 3i over 5i. Now, it is true that you could just multiply it by the conjugate, right? I. So this is 0 plus 5i. So the complex conjugate would be 0 minus 5i. So you multiply the top and the bottom by negative 5i. And if that's easier for you to remember, it's fine. But actually, what you can do here is, since this is a simple term here, and there's an imaginary number but not a real number, all you need to do is multiply the denominator by I and the numerator by I. And that'll be enough to be done. So here, you distribute the I, so you get 4i plus 12i squared. In the denominator, you get 5i squared. I squared is minus 1, so you get 4i minus 12 over 5 times minus 1. I'm going to work down here. In that case, you get 4i minus 12. But actually, I want to write it a plus bi, right? So I'm going to write the real part first. So let's erase there, and let's get minus 12 plus 4i over minus 5. And now I'm going to break this up. I get minus 12 over minus 5 plus 4 over minus 5 times I. And then I just simplify. I get 12 fifths minus 4 fifths I. And that's all we do. So that's part 2 of a series of videos on dividing complex numbers. There's one more video to watch, and that's a series of problems to work through.